Okay, now we're going to do a more complicated example. So this one's based on an experiment that's trying to prove that mind reading exists or doesn't exist. So this experiment, it's a very classic experiment. It requires two participants. And for a test of psychic abilities, researchers have asked the first participant to draw a card at random from a deck of cards with five designs. So they have sort of five cards that they're going to choose from. And these have a star on them, a circle, a plus sign, a square, or three wavy lines. And so the first person picks one of these cards, maybe they pull out this plus one at random. And the second participant, who can't see the cards, makes a guess about what the first participant has drawn. And they repeat this for 10 trials. And each time they put all the cards back, so they're always starting from having all five options. So this first problem that we want to get, we want to find the probability of getting five correct answers out of 10 trials. But before we start, we have to think through, have we met all four requirements to use the binomial model? So the first requirement is about that fixed number of trials. And we are looking at 10 turns, right? 10 trials here. So n equals 10, and that one is met. Number two is that we have two outcomes here. And you might look at these cards and say, wait, there are five outcomes because there are five cards. But really, we are focusing on if the person guesses correctly, right? So if they're guessing correctly, we're really just saying, did they get the right card or not? So they're either correct, they're like, you have a plus, and that was the card I pulled, which would be one option. Or they get it wrong. They said, you have a square, and I'm holding the plus. That would be wrong. So those are the only two outcomes really focused on here. Number three is we need the same probability of success for each trial. And here we're saying that they're just guessing. So if I've picked my card, they have a 1 out of 5 chance of getting it right. And that's my p-value. As a decimal, we're going to call that 0.2. So 1/5 is the same as 0.2. And so that one's also met. And last, four is if they're just guessing, if the person has no psychic ability, then yeah, every time they're guessing, and it is independent. Okay, so all four requirements are met here. Now, to get the probability of getting all five correct answers, we are going to use Binomial PDF on our calculator like we just practiced. The number of trials goes first, and that's 10 trials. The probability of success for each trial is that 1/5 or 0.2. And the number of successes I'm interested in here is 5. And when I put that into my graphing calculator, I get 0.0264, which tells me that 2.64% of the time, which is like roughly 1 in 40, right? Even if the person's just guessing, they get half correct, right? That's a pretty big percentage for just guessing to get half correct. Now, let's look at the very slight change in the next problem. So instead of saying that they get exactly 5 answers, so our first was exactly 5 correct answers, this is 5 or more correct answers. Okay, so that's a little bit different. So when I think of 5 or more, well, they could get 5 correct, or 6 correct, or 7 correct, or 8 correct, or 9 correct, or they could get all 10 correct. So here, 5 or more, there's actually 6 different probabilities I'm going to have to find and add up. So the first thing I'm going to have to do is binomial PDF of what we just did. So that's 10, comma, 0.2, comma, 5. So that's the probability that they get 5 correct answers. Then I'm going to add on to that the probability that they get 6 correct answers. So that's 10, 0.2, and 6. Then I have to add on to that binom PDF that they get 7 correct answers. And you can see that as I go, the only thing that's changing is the number of correct answers. So after 7, we've got 8 correct answers, and then 9 correct answers. And lastly, the maximum number of correct answers they can get is 10 correct answers. So that's why I stop with 10, is because they can't get more than 10 right. And so I would figure out all 6 of these on my calculator and add them all up to figure out this one. So when I do that here and I add up all of these probabilities, and I'm very careful and I don't round until the very end, I get that this probability is equal to 0.03279. Now, this third problem here is really, really similar, and I'm not going to go through the whole thing like I did with this one, but I just want to point out that the language change is now fewer than 5 correct trials. Okay, so 5 or more was 5 and bigger. Fewer than 5 is all the numbers less than 5. So I could get 0 right, I could get 1 right, 2, 3, 4, and 4 is the last number of successes that's less than 5. So these are the ones where I would have to find all of these probabilities and add them up to get the correct answer. Now, if you're looking to do this one and you want to check your work, the answer is 0.9671.